talk a little bit about what an inverse does, okay? Guys, if I have a function, then what does that mean? It means for every input there's and what kind of an output? A unique output, right? A unique output. Well, what does an inverse do? An inverse takes inputs and outputs and switches them around. Okay, well, I mean, that's the really, really easy explanation, right? That's the simple explanation. If we talk about things a little bit more, maybe a little bit more sophisticatedly, is that a word? Sophisticatedly? With more sophistication? Yeah, how about that? If we talk about things with more sophistication, the way I like to think about it is this. We know that something is a function graphically because it passes what? The vertical line test, right? Because it passes the vertical line test. So think about this, right? If I tell you simply that what? An inverse, right? An inverse exists because it passes not a vertical, but a horizontal line test, right? So that brings into play a concept that you guys did in Algebra 2 called one-to-one, right? One-to-one. What does one-to-one mean? It means that it passes the horizontal line test and the vertical line test, right? So in other words, for every input, there's a unique output, but also for every output, there's a unique input, right? Okay, so here's what I'm going to tell you guys, a couple different things. One, here is a function f of g, or just, no, it's not f of g, it's just f of x, right? And these are the values on it. So what are the values on the inverse? What are they going to be? 5, 2, and 6, 3, and 2, -1, right? And and another one, and 7, 4. So we already know that. All right, how about in example B? So that was example A. How about in example B? How do I take f of x equals 5x minus 8, and how do I find the inverse? Switch x and y, absolutely, right? Absolutely. So this is, right now that's a y value, right? So we'll make it x equals 5y minus 8. And that is the inverse, right? Now, guys, would I write it like that? Or would I write it like what? This now, right? Yeah, so I'm going to say f to the -1 of x equals that, right? And how do I take a graph and write an inverse? Yeah, I mean, just switch them. Yeah, I mean, if this point up here is the point 5, I guess I can't even really tell what that is, but if it's 5, 4, then I'm going to plot what? 4, 5, right? If this is the point 1, 1, I'm going to keep 1, 1 because 1, 1 switched to still 1, 1, right? If this point right here is -1, 0, I need to plot 0, -1. All right, so we try to 1, 2, 3, 4, -5. So I think that part looks pretty good. This part's got to stay. Kind of looks something like that, right? Guys, give me another way to think about this graphically. An inverse is A what? Give me a word. Reflection of f of x in the line y equals x, right? Because my f of, or my y equals x would be right there, right? So you guys already know all that information. That's nothing all that new. So far so good? Cool. Guys, what do you notice about the slopes here? This is kind of a tough one, but if I ask you for slopes of tangents, they all agree in terms of sine, right? Like the slope at this point would look, actually let's do this point, would look like that, right? And then at the corresponding point, it would look like that, right? So they're not the same, are they? But they're both what? Brandon said it. Positive. They're both positive, right? So the sign didn't change. The slope did, though. If I look, Austin, right here, right? Here's a perfect example. If I look here, along the green curve, it's that, right? Along the black curve, it's like that, right? Still both positive, right? Still both positive. Anybody want to venture a guess as to what relationship they have? What? So in other words, anybody want to venture a guess as to what the slope is of this compared to the slope of that? They're not perpendicular, because if they were perpendicular, one would have to be positive, one would have to be negative. These are the same slope. Or not, I'm sorry, they're not the same slope. They're the same sine, right? What do you think? They're what? What? Flip. The reciprocals. Yeah, they're actually reciprocals. Yeah. So the slope of this, if the slope of this was like 4, the slope of this would be like 1/4. Okay. If the slope here was 2/3, the slope here would be 3/2. Okay. So they're reciprocals. Okay. All right. Right. Let's write that down. What do you know about the slopes? So the slopes at corresponding values are reciprocals. All right. Guys, think about that for a minute. Hang on. How do I find a slope? Change in y over change in x, right? So if I take an inverse, what did I do? It's x and y. Now it's change in x over change in y. Hence, why the slopes are what? Reciprocals. Make sense now? Okay. All right. So I want to show you guys a quick little thing. This shows up all the time on AP exams. Okay. And it's this. We know that we have an inverse function if I can do this. Now, when I write that down, it never really means much, okay? When I write that down, it never really means much. So I actually want to spend a minute and I want to show you guys what it does, okay? So you can just sort of watch. You don't really have to write this down. But if I show it to you, I think you'll get it. All right, so I'm going to give you this function. Here's my function. Cool? All right. If I want to find the inverse of that, I'm going to take this and do what? Switch the x and the y. If I solve for y, I get that. Divide by 2. And so the inverse would be x minus 1 over 2. Okay? Everybody agrees with that so far? All right. Well, what this rule says is if I have two functions and I need to know if they're inverses or not. One way I can do it is by accomplishing this task. And what this task says is if I take this and plug it into that, I should get x. And if I take this and plug it into that, I should get x. Because what it said was that the inverse is now going to be called g of x. So g of x is said to be the inverse. So if g goes into the original, or if the original goes into g, I should get an outcome of x. It sounds a lot like a lot of words, right? Well, let me just do it, and hopefully that'll connect the dots. So I'm going to call this function g of x, okay? And then what I'm going to do, Austin, is I'm going to compose these. I want to see what happens when I do that. So what does that mean? It means I'm going to take this and I'm going to plug it in here. So G goes into F, right? Well, what happens with this 2 and this 2? And I get x minus 1 plus 1, which is x, right? Well, if I did it the other way around, I would have what? I would take this and I would plug it into there now, right? And I would get 2x plus 1 minus 1 over 2. And what does that give me? 2x over 2, which is x. So did it work? Yes. And if it works, Brandon, what does that mean? It means that this and this must have been inverse functions. Okay? If you don't get x, they weren't inverse functions. Is that cool? All right. That is a way that you're going to see problems presented sometimes where instead of them saying here's an inverse, they give you this. You'll see it in a little bit. Just kind of did the concept make sense? Don't worry about the application yet. Okay? Good? All right, so now we go down here. And here's what this is basically saying. It's saying, ready? Brandon, this is going to sort of put this together for you. It's saying if, or not if, but let f and g be inverses such that if g goes into f, I get x, and if f goes into g, I get x. So I know that it works, correct? Cool. So here's what I say. I say that then, if I was to find the derivative of g, it's the same as 1 over the derivative of f. Okay. I don't know what we're going to do with that quite yet, but we'll find out. Cool? All right, so we're going to star this. This is going to be important. Again, right now you don't know what you're going to do with it, but let's assume it to be true. Okay, flip the page. Here we go. All right, here's what we're going to do. I give you a curve f of x equals x cubed, and I tell you that it's 1 to 1. Do you guys have an idea what that looks like graphically? X cubed. Yeah, sure, right? It's going to look something like that, right? So I have a few questions that we're going to answer, and it's going to sort of give you an idea what you can do with that previous formula B, okay? That's what it's going to do. So here's what I want to do. I want to find f of 2, right? Did I ask for anything really crazy right there? All I asked you to do is to what? Take 2 and plug it in. All right, so f of 2 is 8. All right, cool. Now what do I want you to do? Take the derivative? Take the derivative? Okay, what's my derivative? 3x squared. All right, now what do I want you to do? Now I want you to find the derivative what? The derivative at the value of 2, right? So the derivative at the value of 2 is 12, right? It's 12. Now what do I want you to do? Find the inverse, right? Find the inverse. So if if f of x is this, then I can rewrite it as that, right? What's the inverse? I have to do what? I got to switch them around. And then I got to solve for y, right? So what am I going to do? Take a cubed root. So I get that. All right, so what am I going to say? I'm going to say the inverse is equal to the cubed root of x. Guys, could I graph that on here? Yeah, of course I could, right? Okay. Now what do I want? The derivatives. I'm sorry, the inverse is what? Derivative. The inverse is derivative. The derivative of this, right? All right. So the inverse is the cubed root of x. Another way to write that is what? X to the 1/3. And the derivative of that is going to be what? Because you did what? You subtracted 1 from 1/3, right? Can I write that a different way? Make that look a little prettier? One over cubed root of x squared. Very good. Why did I put that on the bottom? Because it was a negative exponent. Yeah, good. Okay, now what do I want? Now I want to plug 8 into this, right? Okay, well, let's plug 8 into it. By the way, you don't really know why I'm doing all this. We'll connect all these dots in a moment. Uh, 8 squared. 64. Cubed root of 64. Like 112. Okay, now what do I want? The same thing? Oh, hang on a minute. Let's do this one first. What does it ask me to do? 1 over. Yeah, this one shouldn't be here. Sorry. Yeah. Yeah. No, nothing secret there. No, sorry. Nothing secret there. Sorry. Now what do I want? I want 1 over f prime of 2, right? What's f prime of 2? 12, right? What do you notice? These two things match. Okay, so let's break down what we just did. Okay? Because it doesn't see it just seems like a whole bunch of gibberish, right? Here's my x cubed. Everybody agrees, right? My inverse. What's my inverse going to be? Going to be a reflection of this in the line y equals x, right? So can we all get on board with the fact that it's going to look like that? Fair to say? That's going to be cubed root of x. Again, this is my original. This is my inverse. Okay, everybody's good with all that so far? All right, so let's break it down. At a value of 2, it said I was at 8, which is right here. Is that cool? Then it said that I took a derivative. And at 2, I got a derivative of 12. Talk to me about what that means. Talk to me about what that means. The slope of which curve? Yep, of the original curve at 2 is 12. Yeah, so were I to put a what? were I to put my tangent line on there, I would get a slope of that line equal to 12. Okay? Is that good? All right. Then what do we do in the next step? We found our equation for our inverse, right? And then what did I actually do in this step? I plugged in what? I plugged in 8, and I got an answer of, actually, hang on. One more thing I want to do first before I go to that. If I go to this blue curve, right, and I go to 8, where am I? I'm at 2, right? Okay. Sorry, I had to put that little sign in, okay? So we took the derivative of the inverse right here, right? So this equation, Yatin, represents the equation of the blue, right? And this is the derivative of that, right? So now I'm going to find the slope of the blue curve at what point? At 8. Why at 8? Because isn't that the point that corresponds to this one? Okay? And what does this suggest? It suggests that the slope is what? 1/12, right? 1/12. So the slope of this is 1/12. Okay? Now we know why it is because what did we say? When you what? When you switch in, when you create an inverse, you're switching x's and y's, and it's a reciprocal, changing your x and your y values, right? So the fact that we have a slope of 12 and a slope of 1/12 isn't all that impressive, right? But what is impressive is this very last thing, right? And what we said was if I want to know the slope of my inverse at a corresponding point, it's the same as 1 over the derivative at the x values corresponding point. So in other words, if I never what? If I never did any of this, if I never took my derivative, right? So let's suppose, you know what? I can't take the derivative of something because it's too difficult, right? So if I know the original curve, what can I do? Find the corresponding point and do 1 divided by that value. And you're good to go, okay? So we're going to see that played out here, okay, over the course of the next couple of problems. So here I give you an equation. And what we want to do is show that it's always 1-to-1. Show that this graph is always 1-to-1. What would make it 1-to-1, guys? Give me something about this curve that I know is true. All right, that seems reasonable. Okay, that seems reasonable. What if I took a derivative? What if I took a derivative? What would taking a derivative accomplish here? It would give me slopes, right? It would give me slopes of my original curve, wouldn't it? So watch what we're going to do. I'm going to take my derivative, and I'm going to get this. Okay, Gould, ready? If I plug in 0, what do I get? 2. If I plug in -1, what do I get? 7. If I plug in +1, what do I get? 7. Is there a value that you can plug into this function that gives me something less than 0? Why not? Because this is an even function. There's and then I'm adding something to it, right? And multiplying by 5. There's no way that this is ever going to be a number less than 0, right? So what does that mean? It means everywhere on this curve, the slopes are what? Are positive. So it's always increasing, isn't it? If it's always increasing and never decreasing, is there any way it can't be 1-to-1? Right? So in other words, watch this. I'm going to put my pen here. I have to always increase. I have to always increase. I have to always increase. Have to, right? That's what this says, doesn't it? Is that function 1-to-1? Yeah, absolutely. Does that make sense? Okay, so here's what we know. Since the derivative is greater than 0 for all values of x, f of x must be 1 to 1. Right? Evan, does that make sense? Cool. All right, I'm going to guide us through this question now, Austin. Ready? Find f of 1. So we plug in 1. Gould did it a minute ago. Oh, actually, she plugged it into the other one. So we have to plug this one into the original, right? Gives us 2. So talk to me about what that means. That means on my original curve is a point, right? That means on f of x lies the point 1, 2. Can we all get on board with that? So what is this asking me to do? It's saying on the derivative, hang on a minute. Let me try that again. It's saying on the inverse, find the derivative at 2. With me? On the inverse, find the derivative at 2. So let me ask you this question. Evan, do I know what point corresponds to 2? Yeah, it's this, right? So I know that 1, 2, oh, actually, I already wrote that down, right? On f of x lies 1, 2. So on the inverse lies 2, 1, right? So 1, 2, and 2, 1 are corresponding values, right? Now, Brandon, I don't know a graph of this, right? But here's what I do know. I do know that it's always an increasing function, right? You don't have to draw this. I know that at 1, 2 is a point, and I now know that on the inverse, and I kind of have an idea what the inverse looks like. It looks like that, lies the point 2, 1. Make sense? Okay, what do I want to know? I want to know what is the derivative on the inverse at 2. So I want to know what is the slope of this curve at that point. Well, guys, can't I just find the slope on this curve and then do what? Put it under 1, because that makes it a what? Reciprocal. Okay? So what I'm going to do, I have the derivative right here, don't I? Yeah. So at 1, the derivative is 7, right? Say it again. Well, B, come on, B. On 1, I'm at 2. At 1, I have a what? What is this? What does this represent? The slope of the curve, yes. So at this point, the slope is 7. So guys, at the corresponding point on the inverse, the slope is 1/7. All right. So at the corresponding point, the slope is 1/7. So do we see how that can be useful, right? Now, guys, hey, listen. If I really needed to, what could I have done? I could have taken an inverse by switching x and y, which probably would have required me to have to implicitly differentiate, because now this would have been y to the 5th and 2y. Agreed? Right? So yeah, I could go through all that if I need to, and I have the skill to now, but this is like talking about what? I only have an hour to do 25 multiple choice questions. I need to move, right? So let's find the most economical way to get there, all right? So again, look at this, right? Does it make a lot of sense, guys, for me to try to find an inverse of that? Right? Could I? Yeah. Seems like an awful lot of work, right? So here's what I want to know. First thing, what is f of 0? Well, f of 0 simply means I need to do what? Plug in 0, and what do I get? I get 2. How do I know that? Because this goes away, and this goes away, and this goes away, and that's left. So what does that mean? That means that 0, 2 lies on f of x, which means 2, 0 lies on the inverse. Oh, how convenient. They want to know the derivative of the inverse at 2. Well, if I know the derivative of the original at 0, I can just simply plug it in and put it over, or put it under a 1. So our derivative is 2x to the 4th. You agree with that? Because what happens when I multiply 2/5 by 5? The 5's what? Cancel. What's left? Just the 2, right? So it's 2x to the 4th. 3 times the 3rd? 1. So this becomes x squared. So plus x squared plus 3. All right. So what is the slope of the curve at 0? Well, it's obviously 3, right? So what does that mean, guys? That means the corresponding point must have a slope that is the reciprocal of that, right? The corresponding point is at 2, and that must have a reciprocal slope of 1/3. Is that cool? Right? Are we getting it? Can we visualize what happens, right? Because we're seeing it happen right here. We saw it happen over there. Right? Again, are there other ways to do it? Of course. It just would be foolish to do so. Brandon, this answers your question from earlier. Okay? This answers your question from earlier. It says n of x equals x and n of m of x equals x, right? I mean, I said that twice, but we all agree with that, right? Well, guys, if this is all true, what does that mean? It means m and n are inverses, right? So that's a way that the AP exam is going to give you an inverse sometimes, okay? So that means that m of x and n of x are inverses. So now they give me all the ingredients. I just have to know what to do, okay? So what do I know, guys? I know this piece of information. That means that on m of x lies the point what? 5, -9. Well, if n of x is its inverse, then on n of x lies -9, 5. True? All right, so let's just really quickly talk about what's happening graphically. There's one point, right? That's on some curve n of x. Here's another point that lies on m of x. Okay? Now, here's the deal. I got no idea what this looks like. There's one curve. Maybe that's n of x. If that's what n of x looks like, then I have a pretty good idea what the next one looks like, right? So maybe it looks like that. I don't know. Yeah, kind of, right? Close enough. It's just a reflection, what, in the line y equals x. Yeah, so it's good enough. Yeah, we don't know what it looks like. But here's what we do know. Ready? Actually, I didn't draw it. I didn't draw it, so it's going to work. But so let me redraw it. And how do I know that, guys? Because what does it say? It says that the slope of m at 5 needs to be what? Negative. All right, so let's do it right. The slope of m has to be negative. So maybe it looks something like How's that? Right? So now what would the other one look like? Maybe it would look something like, let's see. If that's here, I don't know. Maybe it would look, I don't even know. Anyways, you get the idea, okay? So here's what we're going to do. Ready? Brandon, what is it saying? It's saying that at this point, I have this slope, right? Boom. Which means that what? At the corresponding point, I have to have what slope? The reciprocal of that, which is, give me the right sign, negative 11/8. Got to be the reciprocal, right? Because it's a corresponding point. Man, that's an awful picture. Ugh. That was brutal. All right. So again, what did we see there, guys? We saw representation involving equations. We saw representation involving a graph here, and we'll see that in a minute. Now we got a chart. And again, Brandon, what is this telling me? What's an inverse? F of x and g of x are inverses. And what does it tell me? It tells me, oh, okay, so hang on. F of x and g of x are inverses. It tells me that, oh, we want to find this. This is what we're trying to find. We're trying to find g prime of -3. That's what we want to find. There's not a lot of information up here, is there, guys? Okay. But let's see if there's a piece of information that we maybe can get out of this. Look at F. These are 3 points that are on F, right? I got -3, 4. I got 4, -8. And I got 7, -3. Now, what are the points? So let me write this down. On F are the points -3, 4, 4, -8, and 7, -3. Well, what does it say about g of x? It says on g of x is the point -3, 7, and what? 4, -3, and what? 7, 9. Notice something about that, guys. How much time we got? What time are we done? 6 after? All right. So we'll finish this problem, and then I think we'll stop here. Okay. So notice something about this problem, guys. Boom, boom, corresponding points, right? Boom, boom, corresponding points, right? So that sort of confirms what's happening, right? Feel pretty good about that. I want to find, guys, the derivative at -3. Well, it just so happens that I know everything about that, don't I? I know that g of x actually, I'm not going to write that down. I guess I'm going to do it this way. Ready? Brandon, tell me if this makes sense. I know that if I, hey, don't write it down. I said, ask me if this makes sense. Right? This is the derivative of g, right? Okay. Don't you guys agree? I just want to should I just give it, do I need to be fancy with this? Or should I just get to the point? I don't want to be fancy with it. All right, let me just get to the point. Guys, you agree that -3 and 7 have corresponding points? No doubt about it, right? Because it said so here and it says so here. Everybody agrees with that? Okay. So if I want the derivative at -3, then aren't I really interested in knowing the derivative of f at the corresponding value? And what's the corresponding value? I want the derivative of f at 7. And what was the derivative of f at 7? 2. Well, if the derivative of f at 7 is 2, then the derivative of g at -3, which is the corresponding point, is simply what? 1/2. Yeah, 1/2. Okay. I saw this, and so I'm looking for the corresponding value that matches that. And so at -3 on my g function, which is this one, that's what I was looking for. Okay. I was trying to think of a good way to like write that all out. I think a good way to write it out might be just to simply do this, guys. So if you had to show a little work on this is probably going to be a part 1 type question. But if you had to show some work, you could simply say this. You could say g of x has the point -3, 7, which means f of x has the point 7, -3, right? So we know those are corresponding. So if I want to find this, I simply need to do that. If I want this, I simply need to do that. So I go to the corresponding value and put it under 1. And f prime of 7 was 2. And there's your 1/2. So I guess that would be a way to write it out. And Brandon, that was really the formula that we highlighted earlier, right? There you go.